Hello, we're going to talk about 11.4, and it's called the scalar product, also known as the inner product, inner product, product, but more commonly, I will refer to it as the dot product. So the dot product is the most common way that we represent the dot product. Now, geometrically, what the dot product is when you have two vectors in space, and so I've drawn out vector u, and then there's an angle between the two vectors, and here's angle v in space. Then when you take u dot, when we say this, we don't say u times v, we say u dot v. That's going to be equal to the magnitude of vector u and the magnitude of vector v times the cosine of the angle between the two vectors. And the direction does matter too. So the direction's going this way. So first thing is, I'll apply a proof to this later in a later video, but for right now we're just going to take it to be true. But let's go over some things that we're going to get. Notice that when you take the dot product, right, what magnitude, that would be some length, that would be the length of u, magnitude of v is some length, and cosine of some angle, we're going to get a number out of this. So no matter what, we're going to get some real number out of this, right? So what's interesting about the dot product is when we take the dot product, we're going to get some scalar amount, some real number, where when we added and subtracted with vectors in the past few sections, you know, we got some other vector. Not an actual length, but we get a length out of it, right? Now, the scalar product does not depend on the dimension of space. Just think about it. In space, no matter what, any two vectors, we make some type of plane, so it doesn't matter where it's located in space. So now, this one here, u times v, when we take u times, if it's equal to 0, that implies that they are orthogonal. Now, orthogonal, that means perpendicular. And you can easily see it from this, given that we know that this to be true, that if u times v is equal to 0, right, well, what would this had to have been, right? This angle, for this to be equal to 0, this angle had to be either 90 degrees, right? 90, because the cosine at 90 degrees, what's that equal to? That's equal to 0. Right? So we can see that that's orthogonal. And likewise, if this other one right here, if u times v is equal to plus or minus this magnitude, right, then u and v are parallel. Why are they parallel? Well, that angle, if they were parallel, right, they would have to be, either angle would have to be 0 or pi, or 180 degrees, right? And then either it's going in the same direction or the opposite direction, and it's going to either be positive or negative, whatever those lengths of those two are. So that means that they're parallel. Now, same thing here. If we take this here, it says that if you take the dot product of the same guy, right, that would mean the absolute value would be the magnitude squared. Now, why does that happen, right? Well, if they're u in the same direction, right, then they're going in the same direction. So let's say like something like u and the u in the same direction. You use the formula and you got magnitude u, magnitude u. What's the angle between these two? That's just 0 degrees. What's the cosine at 0 degrees? That's 1. So you get magnitude squared. So, and this is an important property that'll help us with the proof later when we get to it. Now u dot v, if it's greater than 0, right? If it's greater than 0, right? Where is the cosine? Where is the cosine of theta? I'm trying to draw this a little bit better, right? When you have that angle, it's positive in these two quadrants, quadrant 1 and quadrant 4, right? Good. So the angle between them would have to be a positive number. Then we know that that angle is going to be acute. That angle is going to be acute. But when the u times v, the cosine would have had to have been negative, right? And that's in these quadrants. So that means the angle has to be some, that angle theta had to be here, right? And then we know that that one's going to be obtuse, right? And then the last three I'll leave. It's pretty apparent, and if you want to try to prove them yourself, it just takes a little bit longer to do that. But, you know, if you take the dot product, u times v, the u dot v is the same as v dot u. That's commutative. We can use the distributive property. u dot the quantity of u plus b can be u dot b plus u dot this should be u dot b u dot w, and then the scalar product rule, scalar times vector u dot product v is the same as the scalar times the dot product of u and b. So using all these, just some properties that we should be aware of when talking about the dot product. Now let's go ahead and look at an example. Right now, the first 128 says find the scalar product of the vectors u and v given that magnitude u is 2, magnitude v is 3, and the angle between u and b is 60 degrees. So first thing is, I know that u from u dot v, the dot product, is going to be equal to the magnitude u times the magnitude b times the cosine of the angle between them, right? And we know we were given magnitude was 2 of u, and the magnitude of b was 3, and the angle between them is the cosine of 60 degrees. And then we know that 3 times 2 is 6, and the cosine at 60 degrees, that's a half, right? And then the half of 6, that's going to be equal to 3. So the dot product of u and b comes out to be 3. And there you go. Next problem it asks us, it says consider the unit square a, b, c, d. Find the dot product of vector AO and AB. And I've drawn a unit square, so this is A, B, C, D, and 0 is the center of this unit square. Good. Well, we know we're trying to find the dot product between AO, so that would be this vector right here, and AB, right? Well, if this is a unit square and these diagonals are drawn between it, right here, I know that this angle here is 45 degrees. And if it's a unit square, this length is 1, right? This length is 1. And I just need to find out what my, I can figure out this side here. Well, AO, right, vector AO dot product AB, right, is going to be the magnitude of AO times the magnitude of AB times the cosine and the angle between these, which is 45 degrees, right? And we're going to be able to figure out, we can evaluate that one. But AO, I got to figure out what that side is. And I can find that by taking, this ends up being a right triangle. So the cosine of 45 degrees is going to be AO, the magnitude of AO, over the hypotenuse, which is 1. So I know that the magnitude of AO is going to be cosine of 45 degrees is root 2 over 2, right? And then now I can figure out what this is. AO, I've just decided that I've shown that that is root 2 over 2 from below. The magnitude of AB, that's a unit square, so that's 1. And then the cosine of 45 degrees is evaluated at root 2 over 2. And then finally, I can say that AO, the dot product AO, AB, is root 2 over 2 times root 2 over 2. That is going to be 2 over 4, or I can say that's equal to a half. And there you go. Sound good, guys? Thanks.